Okay, here we go. Starting the second half of chapter 7. We'll start with 7.5. Hope everybody's doing really well. Let me share my screen, pull up the notes. You got your blank notes there, and here we go. All right. So first thing, I want you to make a list of factors for these numbers. Okay, so remember, factors are numbers that multiply evenly into a number. So one pair of factors, usually a lot of times you do these as pairs. And that's how I want you to kind of think of doing them in these cases, would be like 1 and 42. Then does 2 go in? Yes. 2 and 21, right? Oh, there's 21's missing. There's the 2 missing out of there. Huh, interesting. So yeah, 2 there. What else? Does 3 go into 42? Remember the divisibility test for 3? Add up the digits, right? So 4 plus 2 is 6. Is 6 a multiple of 3? Yes, it is. That means 3 goes into it. Goes in 14 times. Does 4 go in? No. Does 5 go in? No. Does 6 go in? Yes. Why does 6? How do we know 6 goes in? Besides 6 times 7 is 42, because 2 and 3 work. Remember, that's the test for those. Okay, so try 102 now. And again, I suggest doing them like this because we're going to be wanting to use these factor pairs when we get into factoring polynomials. So start with 1 and 102 and then going to go up from there. All right, I'm going to uncover it now. All right. By the way, notice that when you double one factor, what happens to the other factor? It gets cut in half. Okay. Notice that 3 to 6, 34 is going to be half of that. So it might be an easier way. Like you may not know just off the top of your head that 6 times 17 is 102, right? But if you know that 6 goes into it because 2 and 3 did, then and 6 is double 3, you know the other factor is going to be half of 34, which you know is 17. Okay, and try 28 now. Pause the video. All right, come on back. Hopefully you got 1 and 28, 2 and 14, 3 does not go in, 4 does 7 times, 5 does not, 6 does not, and then we're back to 7, so we can stop. Okay. Ooh, remember this stuff? Determine whether the equation represents a linear or nonlinear function. Okay. This one would be nonlinear, right? If we graph this, it would not be a line. It would be what was actually called a parabola. Okay, and it would open upward like this. And we're going to get all into that stuff in chapter 8. Okay, and what about this one? Yeah, that's linear, right? What forms it in? Y equals mx plus b. I plot a point at 0, -4. I go up to the right one, up to the right one, and then I can draw my line. It's going to be linear. Okay. Awesome. All right, there's this game that we're going to play. I'm going to introduce it here and just do a couple with you that I think we'll play for just for some fun in class. So it's called I Am Thinking of Two Integers. And here's how it works. I literally am going to flash this, and you have to tell me what the two integers are. Remember, integers, so no fractions, no decimals. Can they be negative? Absolutely, they sure can. Can they be 0? Yep, remember, integers, whole numbers and their opposites. So I'm thinking of two integers with a product of 12 and a sum of 8. Remember, product means multiplication result, sum means addition result. So what two numbers multiply to get you 12, add to get you 8? Did you say 6 and 2? Oh, you're so good. You are so good. Awesome. All right, let's try another one. I'm thinking of two integers with a product of 25 and a sum of 10. 5 and 5. Excellent. Way to go. Let's do one more. With a product of 14 and a sum of 9. Yeah. 2 and 7. Way to go. All right. And hopefully we'll play some more of these in class. All right, let's move along. So your learning target for 7.5 is to know how to factor trinomials in the form of x squared plus bx plus c into the product of two binomials. So we're going to take that trinomial there. And by the way, notice how it doesn't say ax squared plus bx plus c. We're particularly wanting the coefficient in this case to be 1. These are kind of like the easiest polynomials to factor. And then we'll add in a number in front of the x squared, a coefficient in front of the x squared, a leading coefficient, different than 1 down the line. But for now, good enough to let's get focused on this. Okay. And you know, oh, we love those algebra tiles. So let's work together on those. And what we're going to be doing here is kind of going backwards in a sense from what we did before, where we had what the binomials were out here and we kind of figured out what this became. Here, we're going to, and as a sample here, we're going to start with the trinomial x squared plus 5x plus 6, and we're going to come away with these. So we're not multiplying out, we're factoring. So just kind of like you distribute in to parentheses, and then you factor or undistribute or factor out. We're doing the factoring out part. We're going from something that doesn't have the parentheses, that's fully simplified, to its factors, to the parentheses. Okay, so step one here in this example is to arrange the algebra tiles that model x squared plus 5x plus 6 into a rectangular array. So here we have that. Remember, these big blue ones with the pluses is an x squared. Green rectangles are positive ones. Red rectangles are negative ones. Remember that. And yellow pluses are positive ones, and the red negatives are negative ones. So this is x squared, and then here's 2x and 3x, and then 6. So x squared, 2x and 3x make 5x, and then 6. Okay. All right. So now we're going to use algebra tiles to model dimensions of the rectangle. So in other words, how are we going to come up with these? Well, doesn't what is in the upper left here in this rectangular array come from the first term of this binomial times the first term here? Yeah, it sure does, right? So what's the only way we're really going to get this x squared is to have an x and an x, positive x and positive x, okay? Well, how are we going to get what's over here? That comes from multiplying this times whatever we put up here. Well, the only way we're going to go from x to 3x is if we multiply by plus 3, okay? All right, where does this part, the bottom left, come from? It comes from multiplying the second term here times the first term here. So how are we going to get to x squared? If we already have an x here, the only way would be to put in a 2 here, positive 2 here. X times positive 2 is positive 2x. Okay, and then what about the 6? Well, it should make sense. If we have positive 2 times positive 3, we're going to get positive 6. Okay? All right, so then we could basically say that x squared plus 5x plus 6 is equal to x plus 2 times x plus 3, or x plus 3 times x plus 2. Okay. All right, so let's try this one, and I've kind of started it a little bit for us. So here's x squared minus 2x minus 1x makes minus 3x, and then plus 2. Okay, what times what is going to make the x squared? Yeah, a bar, right? And a bar. Okay. This times whatever's here is going to make this negative 2x. So what needs to be here? Hopefully you said negative 2, right? Because positive x times negative 2 makes negative 2. All right, well, I got to get a negative 1x here. If I have positive 1x here, what has to be here in order to make it a negative x? Right, a negative 1. And then notice negative 1 times negative 2 makes positive 2. So what are our binomials here? What's this one? This is positive x minus 1, so x minus 1, and this is x minus 2. So we could write that as x minus 2 times x minus 1, or x minus 1, x minus 2, doesn't matter. Okay, try B. Go for it. See if you can get it. Okay, so we have x squared plus 5x plus 4. They've split it up. Obviously, we know we're going to have a positive x and a positive x. And then this is going to have to be multiplied times, hopefully you got positive 4. And then this one's going to have to be times positive 1. So what's our answer? X plus 1 times x plus 4, or vice versa. Okay, and this is what we call factored form. Okay, standard form, factored form. All right. Okay, so now you're going to do the whole enchilada. I want you to write out what the array should be here, and then you're going to figure out the binomials from that. And notice how these C and D are very similar, except it's negative 7x and positive 7x, and that's on purpose. Okay, so go ahead and do it. So hopefully you got an array that looks something like this. You might have had 3 over here and 4 up here. It wouldn't make a difference. Okay. All right, but we know what's going to make the upper left, first term here times first term here, right? So that's x and x. What's going to need to go up here? X times what gets me to negative 3x, right? -3. And what's going to get me the -4x down here if I'm multiplying x times what's here? Perfect. And how would you write that? Go ahead and write it. Hopefully you wrote x minus 4, x minus 3. Okay, and then you can try this one, and this one is similar, except it's going to be all positives, right? So hopefully you got x plus 3 and x plus 4, and that way everything's positive. So what are our binomials here? X plus 4, x plus 3. Okay. All right, and that's what the goal of this lesson is. We're going to be given this, and we're going to be going to this. Okay. And this algebra tiles is actually one way that you can do this. It's probably, as you can see, not the most efficient way, and we're going to learn others. Okay, so factoring x squared plus bx plus c. Writing a polynomial as a product of factors is called factoring. To factor x squared plus bx plus c as the quantity x plus p times the quantity x plus q, you need to find p and q such that p plus q equals b and p times q equals c. What is this reminding you of? What two numbers will combine or add to get me one number and multiply to get you another? What game are you thinking about right now that I introduced you to? Oh yeah, I'm thinking of two integers game. What two numbers multiply to get you this and add to get you this, right? Similar type thing to what we're doing here. Okay. So you're basically saying, okay, what numbers do I need to plug in to make my binomial so that it works? And we've got a number of ways to get you to do this, okay? All right. All right, this core concept here, factoring x squared plus bx plus c when c is positive. So we're saying, okay, c is a positive number, so it's +3 or +5 or whatever, okay? When c is positive, p and q have to have the same sign, okay? Because remember, okay, so like here's our p and here's our q for this example, right? Right, because it's x plus b, x plus q form. If p and q have the same sign, aren't you always going to get a positive? So here, like +1 times +5 gets you 5. Here, -1, -5, when you multiply those together, also gets you +5, okay? And then you might be saying, okay, fine, but then what determines whether I use pluses or minuses? Well, it's the middle term. It's the middle one. Just think about it. When I multiply this out, when I FOIL this bottom one out, x times x squared, obviously. But where does this -6x come from? It comes from multiplying the outies, the outers, right? -5x, and the inners, -1x, and then combining them together because they're like terms and getting -6x. And then this last term in our trinomial comes from multiplying the last terms in the two binomials. -5 times -1 is +5. Okay, so the first way I'm really going to show you of doing this is the one that I learned way back in 1983, 283 school year. Yeah, 82, 83 school year at Palisades Village School. It's called what I call the old-fashioned way, okay? And the way you do this is you list out the factor pairs, and I'll show you what that means. You put in your first terms. You determine your signs for your binomials. You figure out which factor pair works, and then you check by multiplying. Okay, and I'm going to show you exactly how you go through this over and over and over again. Okay. All right, so here we go. Old-fashioned way. Again, here are the steps. Okay, first thing, here's our trinomial. Okay, I got to factor these polynomials. Okay, here's our trinomial. Okay, list the factor pairs. What are the factor pairs of 6? Okay, 1 and 6, 2 and 3. Okay, great. All right, so now we need to put in our first terms. First terms, right, the greens are going to multiply and get us this first term here, right, when we FOIL. So what times what gets me x squared? X and x. Okay. Now, what do my signs need to be? So what you want to do is first you want to look at the last sign. It's positive. Well, the only way we're going to get a positive last term, because we're going to multiply this times this, right, is if it's either two negatives or two positives, right? Because if I multiply a positive times a negative, I'm going to get a -6 or something, and that's not going to work. So it's got to be the same sign, what we just talked about right here, right? Have to have the same sign. Okay. So, and then what you want to do, if you once you know this is positive, it's got to be the same sign. You look here to the middle one, to figure out what the signs are going to be, either 2 pluses or 2 minuses. It's a plus, so it's going to be 2 pluses. So under the pink, we have 2 pluses. Okay. And then here it's kind of trial and error, but you probably are going to get good at this really quickly. What two numbers, which pair, 1 and 6 or 2 and 3, will multiply to get us 6 and combine to get us positive 7? Well, it's certainly not 2 and 3. 2 plus 3 is 5, right? But 1 plus 6 is 7. So we can plug in 6 and 1 or 1 and 6, doesn't matter, and that's our answer. How do we check? Yeah, you FOIL it out, you multiply it back out, make the full circle all the way back to just to check it. Okay. All right, let's go down here. Okay, or actually let's go up to the upper right because that one has less factors as well. Okay, first step, list out the factor pairs. What are the factor pairs of 8? 1 and 8, 2 goes in 4 times, and that's it. Okay, let's put in our first terms. What times what will get me x squared? Well, the only possibility is x and x. Okay, signs. Look at the last one, it's positive. What does that mean? It means it's either 2 positives or 2 negatives. Then we look in the middle, it's positive, so it's going to be positive. Okay, and then which factor is going to multiply to get us 8 and combine to get us 9? 1 and 8. Okay. All right, now let's try this next one down here. Factor pairs of 16, 1 and 16, 2 and 8, 3. No, but 4 does, 4 times. Okay. All right, for signs, what's going to multiply in our greens to make x squared? Yep, same thing. X and x. I told you these ones were not too complicated to start with. Signs, last one's positive. That means either I got to be the same signs. Then we look here, positive. And I hope you're seeing why that's the case. Like why, if this is positive, do we know it's 2 positives? Because think about it. Let's look up here. Where does the middle term come from? Again, multiplying the outsides times the insides. Okay, and we want that to get up to a positive 7. So it's going to be, we're adding them. Okay. And then which factor pair works here to get a positive 10x? 2 and 8. Good. And again, it doesn't matter where you put them because it's x plus 2, x plus 8, x plus 8, x plus 2. It's like 5 times 4 is the same as 4 times 5. Okay, then on this last one, list the factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. Okay. What's going to go into the green to make the x squared? Okay. Now look at the signs carefully. Yeah, it's 2 negatives, right? It's 2 negatives. Okay. And then which factor pair is going to get us product of positive 12 and multiply to get us negative, or combine to get us negative 8, I should say. Yeah, it's going to be the 2 and the 6 because I'd have negative 6x when I multiply the middle and negative 2x when I multiply the outside. Those will combine to get us negative 8x. Okay, we're going to keep going. This is a good place, though, if you want to take a quick break or something like that. Pause it a sec. All right, here's day 2, and yeah, let's do a couple of these. Why not? Let me cover up. There we go. Let's just do a few of them, and we'll play more in class. Okay, I'm thinking of 2 integers with a product of negative 21 and a sum of positive 4. So this gets a little bit more challenging because you have to deal with positive and negative. So the key here is if we're trying to get product multiplication that's a negative, what does that mean? It means we're multiplying a positive and a negative. And then when we combine them to get a positive 4, just got to watch to make sure because this could be a negative 2. You could have a sum of like negative 4. Okay, so what 2 numbers multiply to get you negative 21 and combine to get you positive 4? 7 and negative 3. Good. Notice you couldn't say negative 7 and positive 3. That would get you negative 4. All right, let's try another one. See if you can beat me. Think of 2 integers with a product of 18 and a sum of negative 11. Negative 2, negative 9. How did I know that so quickly? It's positive here, it's negative here, which means it's got to be 2 negatives being multiplied together. Okay. That's the only way to get a positive and to get a sum or combining that's negative. All right, one more. Product of 20 and a sum of 12. 10 and 2. Okay. All right, we'll play more of these in class. All right. So now Remember, what we just did before was the basic polynomials x squared plus bx plus c, where c, the last term, was a positive. Now we're going to do it as negative. I know, and it can be a little confusing. Well, it's plus c, but how, but c can still be negative. So plus and negative is like minus, right? So you can see as we work on these, they're going to be like this example, x squared minus 4x minus 5, okay? Because b could be positive or negative, it doesn't really matter. But again, same thing, when we're going to be thinking of what's going to add to get us the middle coefficient and multiply to get us the last coefficient. So in that way, it's the same analysis, okay? So you can see old-fashioned way, you can see all the steps, the process here, okay? And I have a helpful hint here that we'll get to in a bit, okay? So we'll check that out. But all right, let's start with factor pairs of 21. Okay, 1 and 21, 2, no, 3 and 7, 4, no, 5, no. Okay, that's it. Okay, so what's going to get our x squared? Yeah, same x and x, right? Okay, now we have to think about our signs, right? We're going to determine our signs. What is the signs going to have to be under the yellow to get a last term that's negative? Remember, the last term, this negative 21, comes from multiplying this times this. Well, doesn't it, to get a negative, if we're multiplying two numbers, one has to be a positive, one has to be a negative. And it doesn't matter at this point where you fill them in, okay? Just put in a plus and a minus. Okay, and now here's where it gets a little different. Now we're looking for numbers to plug in that will get us a positive 4x, right? So if I put a 7 there and the negative 3 there, look at my outside, negative 3x and positive 7x makes positive 4x. Well, what would happen though if I put the 3 here and I had the 7 here? So it was x plus 3, x minus 7. When I multiply that, I would get a middle term of negative 4x when I combine like terms. And here's that helpful hint. If you get the opposite of the middle term, just switch the signs. Leave everything the same and switch the signs and it'll work out, okay? All right, let's try x squared plus 2x minus 15. Factor pairs 15, 1 and 15, 3 and 5, right? Okay, what are our signs to make our first term? First term's got to be x and x to make the x squared. Okay. Last term's negative. What does that mean our signs have to be? Good. One positive, one negative. Doesn't matter the order you put them in. And then we got to figure out how we can arrange one of these factor pairs so that we end up getting a middle term of positive 2x. Okay. You can probably see that if you plug in 1 and 15 in either place, that's not going to work. When you combine like terms, you'll either get negative 14x or positive 14x. So that's not going to get us the 2. But the 5 and 3 will, right? But be careful where you put them. So hopefully you put the 3 there and you put the 5 there. Again, you can check it by multiplying. X squared, 5x, negative 3x makes positive 2x. Negative 3 times 5 is negative 15. All right. Here's another way. It's called the STAR method. And I had a student, it was pretty early on when I started at Brentwood. I want to say maybe it was like my 3rd or 4th year. And bright student, Dylan Baker was her name. She actually was so bright that not only was she an accelerated, in algebra AB as a 7th grader, but she ended up skipping 8th grade. Yeah, she went straight from 7th grade to high school. Only student at Brentwood that in my time that I've known have that happen to. So anyway, I was going over the old-fashioned way and all that. She said, "Oh, Mr. Kane, I've learned another way of doing this. Let me show you that." And she called it the STAR method, and so we're calling it the STAR method too. Here's how it works. It's very simple, but you're going to have to, if you want to use this, you're going to have to learn this and not consistently ask me, "How do I set it up? How do I set it up?" All right. So if we have a polynomial in standard form, ax squared plus bx plus c, okay, you make a 6-pronged or 6 whatever star, okay? Upper left, upper right, you put in the coefficient here, okay? So like this w squared minus 4w plus 3, those would be 1s, okay? You then multiply a times c. So in this case, that would be 1 times 3, and you put it up there. You then take the coefficient on your middle term, b, and you put it down here. So the middle coefficient is -4. So I put a -4 there. You then ask yourself, what two numbers can I plug in that will multiply to get you this and combine to get you this? Very similar to what we just did in the game, right? Same kinds of questions. So what two numbers will multiply to get me 3, combine to get me -4? Well, if they multiply to get you a positive, they got to be 2 positives and 2 negatives, right? So, and to get a negative, we can't have 2 positives, so it's got to be negative. So it's what? -3 and -1. Okay, and then the last step for this is we have to write these as binomials. If you can reduce either of these fractions, this 1 over -3 that's here or 1 over -1, do so. In this case, we can't. You then write these as binomials, where this ends up being the coefficient on your x term, and the bottom, this -3, ends up being the constant. So this becomes x minus 3, or 1x minus 3. What would this one become? 1x minus 1, or x minus 1. Again, how can you check? Multiply it out. You can get that. All right, so let's try this again. All right, what's going to go under the greens? The a, remember this is 1n squared. So we would put 1s in. What goes under the purple? A times c, 1 times 35 is 35. And then b goes down below. Just take the coefficient. Remember, always take the sign with it. And then you're saying what two numbers will multiply to get me 35 and combine to get me -12? So you're looking at for factor pairs of 35, it'll get you a -12. Oh, yeah, -5 and -7, right? Look to see if you can reduce this fraction, 1 over -5. You can't. So write it as a binomial. See if you can reduce this fraction. You can't. Write it as a binomial. Okay. All right. So let's try these. We'll do 2 of these star method. We'll do the middle one old-fashioned. Okay. All right. Go for it. All right. I'm back. So obviously we're going to have 1s there. A times c is 24. B coefficient is -14. The two numbers that will multiply to get us 24 and combine to get us -14 are -2 and -12. And can't reduce those fractions, 1 over -2 and 1 over -12. Write them as binomials and check. X squared, -12x and -2x make -14x. -2 times -12 make +24. Check, check. Okay, let's switch gears. Go back and do it the old-fashioned way. So we have 30. List out your factor pairs. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, first terms to make y's, it's going to be a y and a y. To make a y squared, excuse me, is a y times y. What do our signs need to be if my last term's negative? Oh, 1 negative and 1 positive. And then which factor pair is going to combine to get me 13? Remember, we've got a positive and a negative. So wouldn't it be -2 +15? And then check it. Y squared, okay. 15y, -2y makes +13y. -2 times 15 is -30. Cool, it worked. Okay, back to the star. What's a in this case? 1, right? It's 1v squared. What's b in this case? -1, right? Because it's -1v. And then what's c? -42. Okay, so here are your a's, right? A times c, b. What two numbers will multiply to get me -42? Tells you there's got to be 1 positive, got to be 1 negative, and they can't be very far apart if the difference, or when you combine them, it's only -1. And it's not in terms of absolute value, right? It's 6 and -7. Can't reduce these fractions, write them as your binomials. Simple as that. Okay. Okay, a farmer plants a rectangular pumpkin patch. Ooh, there's the pumpkin patch in the northeast corner of a square plot of land. The area of the pumpkin patch is 600 square meters. So this area right here, okay, 600. What is the area of the square plot of land? Well, it's going to be a lot more than 600, isn't it? All right. So, well, if we can figure out what the dimensions are of this plot, right? Then we can know the dimensions of the square, right, or the side length of the square. So what can we set up to figure that out? Well, don't I know the area of this is 600, right? And I know that if this is S all the way across here and this is 40, this dimension right here, or this part of that side is what? It's S minus this part would leave me with this part, so S minus 40. And what about vertically here? If this is all S, and that's 30, isn't this part S minus 30? So you can write those, okay? And then what can you do? Well, we can multiply it out. S squared, negative 40s and negative 30s make negative 70s, and then negative 30 times negative 40 is positive 12 with 2 zeros on the end. Okay, now watch what I'm gonna do. I'm gonna subtract 600 from both sides. Why? So that I get it in standard form, set equal to 0. And now I'm going to factor this polynomial. So again, you do it the same way. You could use the star method, big numbers, but you could use the star method, or you could do the old fashioned way. And what you notice is that you get S minus 10, S minus 60, okay? Which means what? What does S equal? Well, if I set each binomial equal to 0, S minus 10 equals 0, that means I'm gonna add 10 to both sides and S equals 10. And S minus 60, I would add 60 to both sides and S equals 60. Okay, so done that. And so what's the area? What do you think? Wait a minute, how could we have two different answers for S? Whoa, that's weird. What do you think? Why not use 10? Why not? How in the world could S be 10? If this is S and this just part of it is 40, then this entire side has to be more than 40. Yeah. And notice how 60 squared equals 3,600. So it's 3,600 meters. Oh, and it should be not just meters. It should be meters squared or square meters. So I got to label that correctly. Okay. So what if the area of the pumpkin patch is 200 square meters? So instead of 600, it's 200. Is there any difference in how we do this? No, it's done the same way. We just have it set equal to 200. So we multiply out, move it over. That way we can use the zero product property. If there's another number on the other side, you can't. Does this factor? Yeah. Which means S equals 20 or 50. But doesn't make sense for it to be 20, right? If we know that it's S minus 30 and S minus 40. So we're going to use 50 squared, which is 2,500. Okay. And then right here is kind of a little concept summary showing what we've done today in factoring x squared plus bx plus c with the different scenarios. Okay. So hope you enjoyed that. I think that's our last slide. It is indeed. And I will see you very soon. Bye.